Hello, welcome back to Oracle DBA tutorial. In this tutorial, we're going to discuss about Java pool, large pool, and stream pools. So in the bigger picture, we have already discussed memory structure, and we discussed share pool, DB buffer cache, redo, keep pool, and recycle pool. In this video, we are going to discuss about all these three pools together. There are nothing much to talk about on these three pools, so therefore I just want to do one video for all these three pools together. So the first one is large pool. Okay, so if you remember from our last videos that we said that we have a DB buffer cache, and then also we discuss about our shared pool. So these are basically small memories where we just allocate depending on, say we want to get a block from the employee table. So these are very small amount, maybe I can allocate 8 kilobyte or 16 kilobyte and so on, right? So these are small allocations. And then another thing is that whenever these buffers are getting allocated, we don't really deallocate or free them. What happened, like once this all the buffer cache is completely warmed up or completely filled, then using the LRU algorithm and touch count, we are going to make sure that we are going to rewrite. That means there is no free concept here. Okay, so these are the memory. So that is how we allocate this buffer cache, and also the same way that we are going to do for the share pool. However, there are certain cases where we do not want to, this kind of scenario is not going to fit. Okay, so that is like we need to allocate using your C, like malloc or C alloc and all those things, and then after we finish that one, we need to free them. Okay, so that is the concept, like why, otherwise we can deal everything on the buffer cache itself. But the reason we are going to do something in a new pool, and that new pool is basically this large pool, the reason is that we want to allocate or deallocate the memory management in a different way. And that is why Oracle gives you a new memory structure that's called large pool. And this pool is essentially used for different things, like say for example, if you remember that in a shared server mode, the so let's go here. So in case of a shared server mode, this UGA is going to reside in the UGA is going to reside here in the SGA, right? So this is what basically, this picture whatever I'm drawing, this is assuming that this is a dedicated server mode. But in a shared server mode, we have PGA that consists only the stack space, and the UGA is actually lies in the SGA. So essentially that UGA in a shared mode, in a shared server configuration, is going to come from the large pool. So the large pool will allocate memory for the UGA requirement for the in case of a shared server mode. The number two is that we do backup and recovery. For the backup, for RMAN disk IO buffer in some cases. So to backup, we need a tool called RMAN or recovery manager, and for the RMAN disk IO, we need to allocate and using from the heap by using malloc or calloc, and we need to free them. So you use backup recovery. And another thing is that whenever there is a parallel execution of SQL statements, then we need to have a allocation, interprocess message, communication between two different processes. In that case, in order to allow for allocation of interprocess message buffer, we need to have a memory that is coming from the large pool. In those cases, buffer cache is not going to help. So this is called parallel buffer. So in these three conditions, we are going to use large pool, and the large pool is a large pool underscore size is the parameter which is going to determine how big is your large pool. Just want to clarify one thing. So basically now we have something called large pool. So large pool does not mean that this is this size is bigger than the buffer cache. In most of the cases, you may have a buffer cache is much more bigger. The total number of cache is much more bigger than the large pool. But the only difference is that in buffer cache at a time I'm going to allocate very small amount of memory, whereas in the large pool I'm going to allocate a large segment of memory. And second difference is that in buffer cache I'm not going to free it, but in large pool after I finish the work is going to free the memory allocation. So that is why I need large pool. Okay, starting from Oracle 8.1.6, Oracle started to inside Oracle server they started to support Java. That means you have so far you probably have known about PL SQL procedure, but you also can write Java stored procedure. So Java stored procedure, basically you run this Java class inside the Oracle database. To for this kind of for running this kind of Java stored procedure, we need a memory structure that is called Java pool. So inside the Java pool we are going to allocate memory so that our Java stored procedure can be run. So remember in our last thing we discussed that in the share pool we have an area where we run this PL SQL procedure. But if, in case of if you have a Java stored procedure, you don't use the PL SQL area of the share pool. Instead you are going to use another memory structure called Java pool, and the parameter is Java underscore pool underscore size. That is going to determine how big is your Java pool. Starting from Oracle 10G release 2, Oracle introduced another product called streams. So streams, just want to give you an example, and then we're going to do what is a stream pool is. So let's say for example here is a Oracle database. So that means we have an instance and data files and all this thing. Then what you can do, whenever something is going on in your database, right, somebody is doing an insert, update and delete, what you can do is like, if for example what happens, you are using this thing, and for whatever reason this, wherever this thing stored got burnt. If that got burnt, then you are going to lose completely all your data and all this thing, right? So like, in case just a disk crashed, then by using the redo log file you can protect your disk, you can get back the data. But what happens if the complete that house wherever you store this server is going to is destroyed? Okay, so to avoid that one, what they do, they use Oracle database in tandem. That means what I'm going to do, so here is my Oracle server, this is my production server. So let's say this is production database server. That means whenever I'm doing insert, something is happening here. Then what I'm going to do, I'm going to replicate this server in another location. That means let's say this is in San Francisco. So here is another place. Let's say this is somewhere in London, or let's say this is Chicago. Okay, so what I'm going to do, I have another database in Chicago. I'm going to replicate this production database in my Chicago database. To replicate that thing, we need, basically that means whenever I'm going to an insert, whenever so basically this is a database, whenever some customer is doing an insert, then same insert should be rerun in this Chicago database. Or else whatever data that been changed here, somehow that needs to be told to this Chicago database, so that they are going to change that. That is called replication. Okay, so to replicate this thing, we need a Oracle product called streams. Either you need that, or you can also use your own way. So you can also you can and then also a lot of other tools are available in the market where you can replicate the database. But if you want to use Oracle's product, then that product is called streams. So if we configure streams, then we need, in addition to all this other structure, we need a structure called stream pool. Okay, so that is what the stream pool does. Stream pools uses for like when I'm going to stream, I'm going to use my stream pool, and stream pool will be used for that. So this is what all about the remaining last three pools. Okay, and then remember, these pools are not managed by any LRU algorithm and so on. So again, the management of those things are different. So with the conclusion, what we have seen so far, that the memory structure is something like this. This is governed by SGA, and then they have their own way of managing that. Some of them are used by LRU, somebody being done by malloc or calloc and all this thing. But as you see that there is a huge complex thing, right? And then I'm just showing you something, not everything. If you want to do like large pool, again is divided into multiple things, right? So how do you manage them? So and then as you learn in the redo buffer example, it's very important to size it properly. If you don't size it, then it's all going to, it's not going to be good. So before Oracle 10G and even 11G, they used to size this thing manually. But starting from Oracle 10G release 2 and 11G onwards, they improve this thing so that you just set one parameter. That parameter is called SGA underscore target. If you set SGA underscore target, that means how much is the total memory that is going to be consumed for this thing. Then what I'm going to do, I'm going to calculate, the Oracle is going to calculate based upon your workload. It is going to calculate what are the sizes for each individual blocks, so each individual cache, and then it's going to manage that one automatically. And also, like during the runtime, if it detects that for whatever reason we are not really using the share pool so much, then maybe something is going to come to the buffer cache. That means the resizing happens automatically. So therefore you don't need to go about tuning the individual pieces. And believe me, if you want to tune the individual pieces, just make sure that you do a clear run. You test it properly, so that in the, like, your impact of your changes is going to act in a positive way, not in a negative way. That means, you may also happen that you may mess it up while you trying to tune it, trying to make it better. You may land up in a worst case scenario. So this is all about your memory structure, and next set of videos we are going to talk about database processes.